Finally, let's discuss migrating existing code to the enhanced mid-range architecture. Now that we have a basic understanding of the new architecture, let's discuss what should be considered when migrating existing designs to the enhanced mid-range architecture. We can simplify migration into four basic areas: interrupts, indirect memory, and paging and banking. Referring again to the core registers automatically saved on any interrupt, the return from interrupt enable instruction now works a little bit different. The old retfi instruction simply did a return and set the global interrupt enable bit. Now all pre-interrupt context is automatically restored. If your application uses the existing method of saving this context in software, this code should be removed from firmware since the peripherals causing the interrupt may now be a little bit different. Traditionally, the IRP bit allowed access to the second 256 bytes of data memory. This bit no longer exists in the new architecture. Therefore, existing code using this method will need to be changed. The fastest method involves updating the FSR high register, which requires a modification to the working register using move literal to working and then the move working to FSR high. Or you could do many bit sets or clears. If your code currently uses the bank iCell macro, then no changes should be made since it is portable into the new assembler. The bank iCell macro performs all the necessary bit sets or clears in 8 instructions and does not preserve the working register. To preserve the working register, simply add 2 lines of code around the bank iCell macro and the firmware will work on both old and new architectures. How about paging and banking? If your existing code uses the page cell and bank cell macros, there's no need to change anything in firmware since these macros are portable and existing code is automatically converted by the new assembler using the MoveLP and MoveLB instructions in the background. Otherwise, updates to the PCLath code using the MoveLP and replacing writes to the status register with the MoveLB instruction will be needed. Let's summarize what was discussed in the preceding web seminar. The enhanced mid-range architecture takes a good thing and makes it better. Both program and data memories have been dramatically expanded, optimizing the architecture for advanced firmware applications, including those programmed in C. 14 new instructions minimize code overhead, optimizing instruction execution time. The completely accessible hardware stack with reset capabilities has been expanded to 16 levels. With more room for future peripheral expansion, more memory, and 8 MIPS operation, the enhanced mid-range PIC microcontroller takes the best features of the existing architecture and improves upon them. For more information on the new enhanced 8-bit mid-range PIC architecture, refer to the resources listed here. Visit the Enhanced Architecture page at www.microchip.com/enhanced. Here you will find a quick link to such resources as application notes, migration documentation, and relevant data sheets for up-and-coming products. The PIC 16F1XXX software migration document covers much of what was discussed in the preceding web seminar, only in a lot more detail. The soon-to-be-released PIC 16F193X family datasheet and collateral resources viewers may also find helpful. For future reference, all PIC microcontrollers incorporating the new enhanced mid-range core will be designated with the PIC 16F1XXX nomenclature. Check back often as new material will be added on a regular basis. My name is Mark McComb, and I thank you for viewing this web seminar.